In today's lesson, we're going to talk about equivalent fractions. Now, a fraction represents a part of a whole. So here we have this pizza, and this pizza is cut into 6 equal slices. One piece of pizza is a fraction of the whole pizza. So if we look at 1/6, this is the fraction that represents one piece of pizza. It is 1/6. 1 is one piece of the whole, and the 6 is the total number of pieces of the whole. Now, some fractions may look different, but they actually represent the same amount. So here we have this circle, and we're going to divide this circle into 8 equal pieces. And then we are going to shade 4 of those pieces. So you can see we've got this whole divided into 8, and then we've shaded 4 pieces. So that represents 4/8. 4 pieces are shaded out of a total of 8 pieces. So 4 pieces of the whole, and the whole is cut into 8 pieces. Then we're going to take this circle and we're going to divide it into 4 equal pieces, and we're going to shade 2 pieces. So we've got 2 pieces shaded, which is 2/4. So 2 represents 2 pieces of the whole that are shaded, and 4, the whole is cut into 4 pieces. And finally, we're going to take this circle and we're going to divide it into 2 equal pieces, and we are going to shade 1 piece. So if we look at this fraction, it's 1/2, where 1 represents 1 piece of the whole, so that's the part that's shaded, and the 2 represents the whole is cut into 2 equal pieces. So we can see that each fraction is written differently, but they all represent the same amount of the circle that is shaded. We call these equivalent fractions. So 4/8 is equal to 2/4, which is equal to 1/2. These are all equivalent fractions. They represent the same amount. So let's look at some fraction strips to see other fractions that are also equivalent. So if we take this strip, and this represents 1 whole. So we're going to take that whole and we're going to divide it into 2 equal pieces. Well, each piece represents 1/2 of the whole. If we take the strip and divide it into 3 equal pieces, each piece represents 1/3 of the whole. Then we're going to take this strip, this 1 whole, we're going to divide it into 4 equal pieces, and each piece represents 1/4 of the whole. We're going to take the strip, we're going to divide it into 6 equal pieces, and each piece represents 1/6 of the whole. Then we're going to take it, we're going to divide it into 8 equal pieces, so that means that each piece represents 1/8 of a whole. And finally, we're going to take this strip and divide it into 12 equal pieces, and each piece will represent 1/12 of the whole. Now we could keep going, but you see I've run out of room, and this is enough to demonstrate our point. All right, so I'm going to shade this right here, 1 piece, which represents 1/2. And then I'm going to draw a line because we're talking about the amount of space that's been shaded on this fraction strip. So what we're actually looking for is other fraction strips that have the same amount that is shaded. So if we look at the fraction strip that we divided into 4 equal pieces, we can see that 2 pieces represents the same amount that is shaded. Then here, this one that we divided into 6 equal pieces, 3 of those, which is why I have this line, 3/6 also has the same amount that is shaded. 4 of these 1/8 or 4/8 is shaded, and as well 6/12. So that tells us that 1/2 is equal to 2/4, which is equal to 3/6, which is equal to 4/8, which is equal to 6/12. These are all equivalent fractions. All right, let's look at another one. 1/3, we can see if we shade in 1 piece here, then we're going to draw our line and see which other fraction strips also have a same amount. So here we can see 2/6 shades the same amount, and down here we have 4/12, which again shades the same amount. So 1/3 equals 2/6 equals 4/12. These are all equivalent fractions. We look at 1/4, and again, draw our line so we can see what other fraction strips line up. And we can see we're down here, we've got 2/8 that shades the same amount of space. And down here, we've got 3/12, which shades the same amount of space. So 1/4 equals 2/8, which equals 3/12, and these are equivalent fractions. So write an equivalent fraction for 6/8. So we go down here to the eighths, and we shade in 6 of them. That is 6/8. So we draw our line, and we see what other fractions part of the fraction strip lines up with this line. And we can see that we have up here, we have 3/4. And also down here, we have 9/12. So 6/8 we could say is equal to 3/4 or equal to 9/12. These are all equivalent fractions. So either 3/4 or 9/12 is equivalent to 6/8. Now we can also see that fractions are equivalent if we use circles. So we're going to take this circle, we're going to divide it into 8 equal pieces and shade 6 of them. Then we're going to take this circle, divide it into 4 equal pieces and shade 3 of them. That represents 3/4. And finally, we have a circle, we're going to divide it into 12 equal pieces and we are going to shade 9 of them. And you can see that in each circle, they have the same amount of space that is shaded. So this is because they are all equivalent fractions, and that will always be true. Write an equivalent fraction for 1/3. So we're going to shade in 1/3. We're going to draw a line and see what other fraction strips will line up with this line. And so you can see here, this 1/4, it goes through that piece, and so that's why it's not part of our equivalent fraction. But we can see here that 2/6 lines up. This is the same amount of space as 1/3. And down here at 4/12, it also has the same amount of space that is shaded. So 1/3 equals 2/6 equals 4/12. These are all equivalent fractions. So again, let's look at it in using a circle. And we will take the circle, divide it into 3 equal pieces, and we will shade 1 piece. That's 1/3. Then we will take this 2/6. We're going to take our circle, divide it into 6 equal pieces, which is represented by the 6, and we will shade 2 of those pieces. That is 2/6. Finally, we take the last circle, we will divide it into 12 equal pieces, and we will shade 4 of them. And that is 4/12. Notice that all of the circles have the same amount of space that is shaded, and that is because they are all equivalent fractions. Now we could also use multiplication to determine equivalent fractions. So if we multiply the numerator and the denominator by the same number, then it doesn't change the value of that fraction, and you have created an equivalent fraction. So if we take 1/3 and we multiply the numerator and the denominator by the same number, again, the fractions will be equivalent. So let's multiply both the numerator and the denominator by 2. And 1 times 2 is 2, 3 times 2 is 6. So 1/3 is equivalent to 2/6. If we multiply the numerator and the denominator by the same number, again, it does not change the value, it gives you an equivalent fraction. So 1 times 4 gives us 4, and 3 times 4 gives us 12. So there are an infinite number of equivalent fractions because we could choose any number, and we could keep multiplying the numerator and the denominator by the same number, and we could keep doing that forever. So these are just some equivalent fractions. Now, John and Kathy both made pizza last night. John cut his pizza into 12 slices and ate 8 of them. Kathy cut her pizza into 6 slices, and she ate 4 of them. Who ate more pizza? All right, so Kathy ate 4/6 of her pizza, and John ate 8/12 of his pizza. So we're going to look at fraction strips. We've got 6 because Kathy divided her pizza into 6 equal pieces, and John divided his into 12 equal pieces. So Kathy, we know, ate 4 of her pieces, and John ate 8 of his pieces. Notice that they line up, they shade the same amount of space, and so we can see that 4/6 is equal to 8/12. They are equivalent fractions. We can even draw pizzas for each and see that the fractions are equivalent. So we've got here Kathy's pizza divided into 6 equal pieces, and she ate 4 of them, so that's 4/6. Then John's pizza divided into 12, and we can he ate 8 pieces. And again, we can see that both circles have the same amount shaded. And so 4/6 and 8/12 are equivalent fractions. So we can, another thing we could also look at is we could look at multiplication. As we said, if we multiply both the numerator and the denominator by the same number, it does not change the value of the fraction. So let's see what happens if we multiply the numerator and the denominator by 2. So 4 times 2 is 8, 6 times 2 is 12, and so we can see that 4/6 is equal to 8/12, which means that Kathy and John ate the same amount of pizza. And that's your lesson on equivalent fractions.